Okay, so let's go to page 203. And I will give you, if you have your study sheet on you right now, I'll give you a strong hint. Right? I'm going to use a different color than I normally use. We're going to start talking about polygons, okay? And polygons is just basically, watch what it says here. Polygon is a closed figure of 3 or more sides on a single plane. So you can just think of poly, think of many sides, a shape with many sides. So a triangle is technically a polygon. A quadrilateral is also a polygon. They just have specific names, right? So they have 3 sides, 4 sides. Pentagon has 5 sides. Hexagon has 6. What I'm going to suggest strongly right now, I'm going to give you a couple minutes. I don't do the gon, right? Just go penta, hexa, hepta, octa, nona, and so forth. Add it to your study sheet. Because you're not going to know how. Sometimes you're going to guess, and the whole question is going to be wrong just because you don't know how many sides that shape has. So I would strongly recommend you make a small box. I would start at pentagon because, I mean, triangle, quadrilateral, you really don't need, right? Just start at pentagon. So penta 5, hexa 6, hepta 7. Just have a small little section where you tell yourself which one is which. And after dodecagon, right, then we just say a 13-sided polygon or a 21-sided polygon, right? Like after 12, there is no specific name. But these ones you're expected to know, okay? And in this course, we're basically just going to deal with regular polygons as well. Regular polygon, what does it mean? It has congruent side lengths and it has congruent interior angles. That means same or equal. Okay, that's what a regular polygon is. So you're expected to know that when I say regular polygon, right away you should be thinking, oh, okay, it's a polygon that has all sides the same. So equilateral triangle, is that a regular polygon? Yes. Is a square a regular polygon? Yes, because all 4 sides are the same. Okay. Is a rhombus a polygon? It is a polygon. Is it regular? No, because the angles aren't all the same. Okay. If a rhombus is slanted, you're going to have 2 obtuse angles, 2 acute angles, so it's not. Okay. All right. Now that I talked about polygons, you're going to take out this handout right there. And I tried something, I know it's cheesy, but you're psyched about regular polygons, right? I know that's not how you spell psyched, but you can you can tell my sense of humor isn't the best, right? But I try something for it to stick, okay? And you will see that, right, there are formulas that are related to each one of those letters, okay? So I'm going to ask you to get this. If you don't have this, as soon as you come in, get it from, it's in the middle of the table here on our desk. And which reminds me, I think I need to make packages, right? For some students. So just get this out, and we're going to do some let me start with saying this, okay? What are interior angles? Well, let's try to make a pentagon here. You start with a triangle like that on top, but then you'll just go down, down, across, right? You've made your pentagon. Sum of all interior angles. A pentagon has 5 sides, and it also has 5 interior angles. So this is a pentagon. 5 sides, 5 angles. Interior angles, that is. And I will just make sure that you know interior. Oh man, we're running out of room there. Let me make the arrow going a little bit more sideways here. 5 angles. There are 5 interior and 5 exterior angles. What? Exterior angles? I never heard of that, right? I'm going to talk about that in a bit. What we know is that the sum of all interior angles, right, would be denoted by letter S, and that would be n minus 2 times 180 degrees. And let's just get over with. N represents the number of sides. Okay. N represents the number of sides for all of these formulas. So if you wanted to know the sum of all interior angles of a triangle, let's say, let's try this in our heads. Triangle has how many sides? 3, right? 3 minus 2 is 1. 1 times 180 is 180, which we know, right? Let's try a square. 4 sides. 4 minus 2 is 2. 2 times 180 is 360, which we know a quadrilateral, any 4-sided shape is always 360. So this is always true. Always true. Okay, so this is your first formula, which, by the way, most of these are on your formula sheet, right? This is, if you wanted to know each interior angle, like what does each one of these individually measure? So for an equilateral triangle, we know it's 60, right? You would have to go n minus 2 times 180 divided by the number of sides. That's your formula for that one. I'll add this later. It makes more sense. So this is how you find each individual interior angle. Central angle is simply going to be 360 divided by the number of sides. That one is easy. What's a central angle? So this would be an I here. That's the interior angle. A central angle is if you were to find the middle of this pentagon. Look up here, okay, up on the page. And if you were to make a slice, right, like that, to each corner of the shape, that in the middle here is called a central angle. Okay, so think about it. It's 360 degrees all around. So if you just want the central angle here, you would just go 360 divided by 1, 2, 3, 4, 5 in this case to get that central angle. So that's where the formula comes from. Exterior angle is the same thing. How can that be? How can that be? Let's go back up here, okay, to this pentagon here. Exterior angle is if you were to look at this vertex right here, and it doesn't matter which way you go, you want to go this way or you want to extend this side, it doesn't matter, but only one of them applies. If you come out and make a dashed line like that, just extending this side, for example, you get on the outside here something we call exterior angle. Okay, so that's how you find the exterior angle. And so the central and exterior are always the same. Okay, but you need to be able to label them accordingly. So the exterior angle is here. How many exterior angles will a pentagon have? As many as they have interior. So if they have 5 interior, then it will have 5 exterior angles. Okay. Again, you could have extended this side and called this exterior here, but you can't have 2 in one corner, okay? Only one. Number of diagonals. That one I need to always remind myself. It's n times n minus 3 divided by 2. And I won't make this diagram up here too messy, okay? We'll just do another pentagon here on the side for the diagonals, just to make a point. So you start with a triangle like this, okay? Then instead of crossing like this, you go down and try to make them all the same length. There's your pentagon. Number of diagonals, this formula tells you how many diagonals are possible in this particular pentagon. So I'm going to use different colors. So red. So from here, I can go across. That's 1, 2, and that's it. So 1 and 2. This would not be considered a diagonal because it's the actual side. So from here to here, so that's 1, 2. I'm going to use blue. I'm going to move over to this corner here. So that's 1, 2 that way. And I'm going to use a different color yet. Where's my black pen? Right here. Right? You start from this corner. You've already done that. The only one left here is to go across like that. Basically have a star inside. So how many diagonals are there? Let's count. 1, 2, 3, 4, 5. 5 diagonals. Okay, Mr. Dirksen, so Pentagon has 5 sides, so 5 diagonals. So that's just how it goes, right? If it is a hexagon, 6 diagonals, no, that's not true, okay? And we will do that. But let's just try those formula ones here. To find the number of diagonals without drawing them, we'd go 5 times 5 minus 3, because we're talking about a pentagon, right? So every n is substituted with that. So that'd be 5 times 2, right? Because this turns to 2 and divided by 2, which is 5 times 2 is 10, divided by 2 is 5. So this is by graphing it, and this is doing it by calculations. The province allows you to do both. I always tell my students just calculate it, because if it's a hepta or an octagon or more, you've got so many lines crossing, you'll probably miss one. I would not recommend that. I would say just calculate it, okay? And I will tell you this on this side here. From E to N, like these here, only no, do not include N here. I'm trying to make it easier for you, and yet I'm confusing you here. From E, the interior angle, which is the I, right? Ice basically only true for regular polys. Okay. So ICE, interior angle, central, exterior, that is only true for regular polys. That would not be true for an irregular. Okay. But most of our shapes are going to be regular. So what are you saying, Mr. Dixon? The S and the D works for all polygons? Yes. The S and the D works for all of them. Okay. Now, let's do some calculating here. I'm going to zoom out a bit. Let's try them here. So I want you to calculate and label ice. Okay. What does that mean? I want you to calculate the interior, the central, and the exterior. So you got to be creative with your space here. Let's do the interior on the side here. Interior. First of all, how many sides does this have? 1, 2, 3, 4, 5. So n here is equal to 5. Okay, that's the first thing you need to identify, or else you cannot do this. The interior angle, if you look at the formula, is equal to n minus 2, okay, times 180 divided by n. Look at the formula up there. Okay. And so I is going to be 3, right? 5 minus 2 is 3 times 180 divided by 5. So let's go ahead and do that. That's 108. So all you have to do is for one of the interior angles here, okay, say that this is 108. This is my interior angle. They're all 108. Each and every one of them is 108. Okay? But you've just found one and you've labeled them. Now we're going to find the central angle. Central is going to be 360 divided by n, which is 5. And that's 72 degrees. It's always degrees. So come to the middle. Doesn't matter where you slice out. If you want to slice out like this, and just say that this is 72, and that's your central angle, you're fine. And the exterior angle, which is the same, but still go ahead and do that, which is 72. I think labeling the exterior is the hardest for students. They don't know where to put the exterior angle. Just go to one of the corners, doesn't matter. Let's say we go to this one here, and you extend this way, like you basically take one side and you extend it like this. And you label it there. That's 72 as well. And that would be all around the shape. So if you extend that side, if you were to extend this side, it's almost like a water wheel, right? 72. You keep going this side, 72. You keep going this side, 72. And then you keep traveling, 72. So the central and the exterior will always be the same. That's a cool thing, okay? What do these two add up to? 108, the interior and the exterior. Do you notice that? If you were to add them up, what do you get? 180. Which, if you think about it, this is a straight line here. So they should add up to 180. Let's see if that's true. So I want you to keep going with these shapes First of all, you have to tell me how many sides does it have. Okay, count them and find out n and then calculate ICE. You know what? I don't know why I didn't make you calculate D, but can I make you calculate D here as well? Iced T, right? You can calculate D. I've already done that here for this shape, and I don't need you to label diagonals. Okay? I don't need you to label diagonals. Just ICE, right? Diagonals, just calculate it and then come up. You should never get a decimal for your diagonals. It will always be a whole number. If you get a decimal, you made a mistake. Okay? Okay, so we've got 10 minutes. Let's do a couple before we go our ways, okay? Just do this one and maybe one more before you go, right? And then tomorrow we'll keep working on this and add some more difficulty to this, okay? So that is your homework. And I will post this as a PDF as well.